Washington's volcano. For example, Snohomish County's Glacier Peak, which is considered highly dangerous, only has one seismometer on it, monitoring for earthquakes, and it's often swarms of tiny earthquakes that are the first sign of an eruption.
Something unusual is unfolding beneath one of Washington's most closely monitored volcanoes, and scientists are paying very close attention. Fresh signs of activity have sparked renewed interest, raising questions about what may be happening deep underground, and whether these changes could signal something more significant. While experts continue to study every new development, many people are wondering how concerned they should be and what the latest findings actually mean. So, what has researchers watching so carefully? And could this become a much bigger story? Let's explore the facts. Hidden tremors spark growing concern. Something beneath Mount Rainier has captured scientists' full attention, and although no emergency warning has been issued, the mountain is once again becoming the focus of intense observation. Small clusters of earthquakes have recently been detected beneath Washington's tallest volcano, prompting experts to examine every new signal with unusual care. Individually, these tremors are not powerful enough to alarm nearby communities, but together they raise an important question. Why is the mountain becoming more active now? And what story might these tiny movements be trying to tell beneath the surface? The first response from monitoring agencies has been measured rather than dramatic. Scientists have emphasized that Mount Rainier remains under normal alert status, and there is no evidence suggesting an eruption is imminent. That distinction matters because volcanoes naturally experience periods of internal activity without progressing toward an eruption. Even so, researchers are paying close attention because history has shown that subtle changes often deserve careful study long before they become obvious to the public. Every earthquake, no matter how small, becomes another piece of a much larger scientific puzzle. Modern monitoring equipment continuously watches the volcano from every possible angle. Sensitive seismometers record underground shaking around the clock, while additional instruments track tiny movements in the mountain's surface. Each new report is compared with years of previous observations, allowing scientists to determine whether the recent earthquake clusters fit normal background activity or suggest something less familiar. The goal is not to predict disasters from isolated events, but to recognize meaningful patterns before they become significant. This careful approach sometimes creates confusion outside the scientific community. Headlines announcing new volcanic activity can quickly spread across social media, leading many people to assume that an eruption must be approaching. Others question whether officials are revealing everything they know, while speculation often grows faster than verified information. Scientists, however, continue relying on evidence rather than emotion. A handful of earthquakes alone cannot explain what is happening inside a volcano as large and complex as Mount Rainier. They must be evaluated alongside every other measurement collected from the mountain. What makes this moment especially compelling is the difference between ordinary activity and activity that deserves greater attention. Volcanoes are never completely silent, yet certain combinations of changes can carry far greater meaning than individual events viewed alone. That is precisely why experts are studying these recent earthquake clusters so closely. They are not reacting to fear, but searching for context, determined to understand whether these subtle signals represent nothing more than routine geological behavior or the earliest hints of a larger process still hidden deep beneath Washington's most closely watched volcanic giant. Rainier's greatest danger may have nothing to do with fire or lava. What invisible force could erase entire communities without warning? Why are experts more alarmed than ever? Which overlooked clue suggests the worst-case scenario may arrive faster than anyone expects. Let's unravel the mystery. Silent giant holds deadly secrets. Many people assume America's greatest volcanic threat must be Yellowstone or Mount St. Helens, because those names dominate documentaries, headlines, and disaster films. Yet, countless volcanologists point somewhere else entirely. They point toward Mount Rainier, a towering peak that rises quietly above Washington state. Unlike volcanoes known for dramatic eruptions alone, Rainier presents a different kind of danger, one that could unfold with little warning and affect hundreds of thousands of people living far beyond its snowy slopes. That unsettling reality explains why scientists never allow themselves to ignore even the smallest changes beneath the mountain. At first glance, Mount Rainier appears peaceful. Its massive summit remains wrapped in snow and ice throughout much of the year, attracting hikers, climbers, photographers, and tourists from around the world. The mountain projects strength and beauty rather than menace. Hidden beneath that breathtaking landscape, however, lies one of the largest volcanic systems in the Cascade Range. More importantly, its enormous blanket of glaciers creates a threat unlike almost any other volcano in the continental United States. Those glaciers are what make Rainier especially dangerous. If volcanic heat, an eruption, or even structural collapse were to rapidly melt large amounts of ice and snow, the result could be devastating lahars. These fast-moving volcanic mud flows are powerful mixtures of water, ash, rocks, and debris capable of racing down river valleys at remarkable speeds. Unlike flowing lava, lahars can travel dozens of miles, reaching communities located far from the volcano itself. Entire towns built along these ancient pathways exist because previous lahars reshaped the landscape long before modern settlements appeared. History proves this danger is far from imaginary. Geological evidence shows that Mount Rainier has produced enormous lahars many times over thousands of years. Some traveled astonishing distances, permanently altering valleys and leaving behind thick layers of volcanic sediment that remain visible today. These ancient events remind scientists that the mountain's greatest threat is not always an explosive eruption towering into the sky. Sometimes, the most destructive force begins as a torrent of mud, moving silently through populated valleys. That reality often surprises the public. Many people picture volcanoes as rivers of glowing lava or towering clouds of ash, but Rainier challenges those expectations. Its greatest hazard could develop without producing the kind of spectacular eruption most people imagine. That difference shapes how emergency planners, volcanologists, and monitoring agencies approach every sign of activity beneath the mountain. The earthquakes alone are not what concern them most. Instead, they represent another reminder that this giant remains alive, capable of changing conditions that demand constant attention. Understanding that hidden risk transforms every new report from ordinary scientific observation into something carrying far greater weight than many people first realize. Every tremor tells a story, yet which ones hide something far more dangerous? Could scientists already be seeing a pattern they hoped would never appear? What hidden signal separates harmless rumbling from the first unmistakable warning of something far greater? Let's find out. Deep secrets never truly rest. Mount Rainier may appear calm from a distance, but beneath its snow-covered slopes, the volcano is constantly alive. Deep underground, heat, water, rock, and magma interact every day in ways invisible to the millions of people living nearby. Most of the time, these natural processes unfold quietly, producing only faint signals that specialized instruments can detect. That constant activity is exactly why scientists never stop watching. A silent volcano can still be active beneath the surface, and understanding the difference between ordinary movement and meaningful change has become one of their greatest responsibilities. One of the mountain's most important hidden features is its hydrothermal system. Hot water and volcanic gases circulate through cracks deep inside the volcano, heating surrounding rock and creating a complex underground network that is always changing. As pressure shifts or fluids move through these fractures, small earthquakes naturally occur. These tiny tremors are not unusual for Mount Rainier. In fact, they are considered part of the volcano's normal behavior, reflecting a living system that continues to evolve even during long periods without an eruption. Far below that hydrothermal network lies an even deeper source of attention. Scientists believe a magma reservoir exists beneath the volcano, supplying the heat that keeps Rainier alive. This molten rock remains well below the surface, but its presence influences everything happening above it. Heat escaping from this reservoir powers the hydrothermal system, while subtle changes in pressure can affect earthquake activity. Even though the magma itself may remain stable for years, researchers understand that every movement inside the volcano deserves careful examination, because deeper processes often reveal themselves gradually rather than suddenly. That is where careful interpretation becomes essential. Volcanoes regularly produce background seismic activity, and Mount Rainier is no exception. Small earthquakes happen often enough that they rarely trigger concern by themselves. The challenge begins when scientists notice changes in their behavior instead of simply counting how many occur. They study whether earthquakes begin appearing closer together, occur at different depths, or develop patterns unlike those seen during routine monitoring. A single tremor says very little, but an unusual sequence can raise entirely different questions. This is also where misunderstanding easily grows. Some observers view every increase in earthquake activity as proof that an eruption is approaching, while others dismiss every new report as routine. Scientists accept neither conclusion without evidence. Instead, they compare each new sequence against decades of historical data, searching for connections rather than headlines. For now, Mount Rainier continues behaving like a restless volcano rather than an erupting one. Even so, its hidden systems remind researchers that beneath the mountain's quiet appearance, powerful forces remain active, and understanding their patterns could become increasingly important as this story continues to unfold. Earthquakes reveal only fragments. What are satellites detecting beneath the ice? Why are glaciers shifting in unexpected ways? Could invisible changes already be unfolding where no one can see, pointing toward a far more alarming discovery than anyone has imagined? Keep watching. Hidden systems reveal silent warnings. The latest earthquake clusters beneath Mount Rainier have drawn attention, but they represent only a fraction of what scientists are actually studying. While the public often focuses on shaking beneath the volcano, researchers know that earthquakes alone rarely tell the whole story. Every hour of every day, an extensive network of instruments quietly collects thousands of measurements, searching for changes that human senses could never detect. Together, these hidden observations create a far more complete picture of what is happening inside one of Washington's most closely watched natural landmarks. Among the most valuable tools are highly precise GPS stations anchored around the volcano. These instruments measure movements so small they can detect the ground shifting by only a few millimeters. If magma begins pushing upward, the mountain may slowly expand before any visible changes appear. Scientists constantly compare new GPS readings with older records, watching for even the slightest signs that pressure beneath Mount Rainier is changing in unexpected ways. Most days, the data shows remarkable stability, but every measurement becomes part of a much larger investigation. Satellite radar adds another layer of observation. Orbiting high above Earth, satellites repeatedly scan the volcano's surface, producing detailed maps that reveal tiny changes across broad areas. This technology allows scientists to verify whether the mountain is quietly rising, sinking, or remaining stable over time. Unlike photographs, radar can measure subtle deformation invisible to the naked eye, making it one of the most powerful tools available for tracking volcanic behavior without setting foot on the mountain itself. Researchers also monitor volcanic gases escaping through vents and cracks. Changes in gases, such as carbon dioxide or sulfur dioxide, can sometimes indicate shifting conditions below the surface. At the same time, instruments measure ground temperatures around geothermal areas, searching for unexpected increases that might signal changes within the hydrothermal system. Even the glaciers covering Mount Rainier receive constant attention, because unusual movement or accelerated melting could provide additional clues about underground heat. None of these observations stands alone. Each one gains meaning only when examined alongside every other signal being collected. This layered approach explains why scientists remain cautious despite recent earthquake activity. Some people assume shaking alone reveals the volcano's intentions, while others believe advanced technology should provide immediate answers. The reality is far more complex. Every instrument offers only one piece of an enormous puzzle, and conclusions emerge only after all the evidence is carefully compared. For now, the monitoring network continues watching without suggesting immediate danger. Yet its constant vigilance reflects an undeniable truth. Mount Rainier rarely gives away its secrets quickly, and understanding its quiet signals may prove just as important as recognizing the loud ones if future conditions begin to change. Millions believe lava is the greatest threat, yet another force has erased entire landscapes before. What danger races farther than anyone expects? Which communities stand directly above its forgotten path? Could history already be preparing to repeat itself? Rainier's deadliest hidden danger. When most people imagine a volcanic disaster, they picture rivers of lava or towering clouds of ash exploding into the sky. Mount Rainier presents a very different threat. Scientists have long warned that the greatest danger may arrive without a massive eruption at all. Instead, it could begin with one unstoppable force known as a lahar, a fast-moving mixture of water, volcanic rock, mud, and debris capable of racing down valleys with incredible speed. This possibility is one of the main reasons Mount Rainier is considered Washington's most dangerous volcano, even during periods when it appears calm. Rainier's towering slopes are covered by one of the largest collections of glaciers in the Cascade Range. Those enormous ice fields are both beautiful and potentially hazardous. If volcanic heat, collapsing rock, or even part of the mountain's weakened slopes suddenly destabilize them, huge amounts of water can mix with ash, loose sediment, and broken volcanic material. The result is a dense mud flow powerful enough to sweep away forests, bridges, roads, and entire neighborhoods lying in its path. Unlike lava, which often advances slowly, lahars can travel with frightening speed, leaving little time for people downstream to react. History proves this danger is far more than a theoretical concern. Thousands of years ago, Mount Rainier produced the massive Osceola mud flow, which carried enormous amounts of volcanic debris far beyond the mountain itself. Centuries later, the electron mud flow demonstrated once again that Rainier could send destructive flows across great distances without creating one of history's largest eruptions. These ancient events permanently reshaped river valleys and left thick layers of volcanic deposits that remain visible today. They also revealed how far a lahar can travel before finally coming to rest. That history carries special meaning because many modern communities now stand on top of those very deposits. Over generations, towns, transportation routes, schools, and businesses developed across valleys once carved by ancient mud flows. Most residents rarely think about the landscape beneath their feet, yet geologists recognize it as evidence of powerful events that occurred long before modern Washington existed. This reality explains why emergency planners continue preparing for lahars even during times of relatively quiet volcanic activity. Some people assume the absence of an explosive eruption means there is little reason for concern. Scientists see the situation differently. They understand that Mount Rainier's greatest hazard cannot be measured only by lava or ash clouds. The mountain's glaciers, steep terrain, and long geological history create a unique combination of risks, unlike most volcanoes in the United States. That is why every new sign of activity is examined so carefully, because the most serious threat may not begin with a dramatic explosion, but with a silent chain of events already taking shape high above the valleys below. Every sensor, warning system, and expert eye is watching Rainier's every move. But what hidden signals are scientists searching for What could trigger the next critical response? And will their preparations be enough when the mountain reveals its true intentions in the moments still ahead? Stay with us. Technology guards every silent signal. As attention remains focused on Mount Rainier's recent activity, another process continues quietly behind the scenes. Before the public hears about earthquake clusters or scientific reports, experts are already monitoring the volcano every moment of every day. Their mission is not simply to respond after danger appears, but to identify early signs of meaningful change before conditions become serious. This constant observation has become one of the strongest protections against the uncertainty surrounding one of Washington's most closely watched natural hazards. The United States Geological Survey and the Cascades Volcano Observatory lead this effort, analyzing information collected from Mount Rainier around the clock. Their work involves far more than recording earthquakes. Every signal is reviewed, compared with previous observations, and studied within the larger behavior of the volcano. Although advanced computers process huge amounts of data, scientists must still determine whether changes are normal or require deeper investigation. Modern technology allows researchers to monitor Rainier continuously rather than depending only on occasional field visits. Instruments positioned across the mountain send real-time information that helps scientists track changes as they occur. Rising earthquake activity, unexpected ground movement, or unusual signals from monitoring systems can be identified much faster than in previous decades. This constant flow of information gives researchers a clearer picture of the volcano's behavior and improves their ability to respond when conditions change. Because Mount Rainier's greatest danger includes lahars, scientists also maintain systems designed to detect these powerful mud flows. Sensors placed in surrounding valleys can recognize the vibrations created by moving debris and provide valuable warning information to communities in vulnerable areas. Even a short warning period can make a critical difference when preparing for a rapidly developing event. However, advanced monitoring does not mean scientists can predict every volcanic event with complete certainty. Volcanoes remain complicated systems, and no single measurement can reveal exactly what will happen next. Experts must examine many different signals together, using evidence and experience to separate ordinary activity from patterns that may require concern. This combination of technology and human judgment defines the modern approach to Mount Rainier. The volcano is constantly watched, but every observation must be carefully interpreted. The real strength of the monitoring system comes from multiple agencies, instruments, and specialists working together to understand the mountain before changes become impossible to ignore. As recent activity continues, scientists remain watchful, ensuring communities understand future changes before serious risks emerge. Decades of volcanic warnings have revealed patterns scientists still fear today. But what hidden signals connect Rainier to past disasters? Could the lessons carved from Mount St. Helens change how experts see this awakening? And what discovery awaits as monitoring intensifies beyond expectations around Rainier? Stay glued. History casts a long shadow. The recent activity beneath Mount Rainier has sparked renewed attention, but scientists are careful not to judge today's signals in isolation. Instead, they turn to history, because every volcano leaves behind a record of how it behaved before major events. Across Washington's Cascade Range, decades of observation have revealed that eruptions rarely arrive without warning. They usually begin with a sequence of changes that gradually become impossible to ignore. Those past lessons now shape every decision researchers make as they study Mount Rainier's latest signs of unrest. No event influences modern volcano monitoring more than the eruption of Mount St. Helens in 1980. Before its catastrophic explosion, the mountain produced increasingly frequent earthquakes, powerful steam blasts, and dramatic ground deformation as magma forced its way toward the surface. Scientists watched an enormous bulge grow along the volcano's northern flank, clearly signaling that pressure underground was rapidly increasing. When the eruption finally occurred, It became the deadliest volcanic disaster in United States history, killing 57 people and permanently changing how volcanic hazards would be studied across the country. That disaster transformed scientific thinking. Researchers realized that no single warning sign could explain an approaching eruption. Instead, earthquakes, ground movement, gas emissions, and surface changes had to be examined together. Modern volcano observatories were strengthened, new monitoring equipment was installed, and scientists developed far more detailed systems for recognizing dangerous patterns before they reached a critical stage. The painful lessons learned from Mount St. Helens continue guiding every observation made throughout the Cascade Range today. Mount Rainier has its own long volcanic history, although it has not produced an eruption like Mount St. Helens in modern times. Over thousands of years, it has experienced multiple eruptive episodes and generated destructive lahars that reshaped surrounding valleys. Those events remind researchers that Rainier remains an active volcano, even during long periods of apparent quiet. However, its recent earthquake clusters do not currently resemble the rapidly escalating sequence observed before the 1980 eruption. That distinction is one of the most important conclusions scientists emphasize. Even so, similarities are never dismissed without careful investigation. Researchers continually compare present-day measurements with historical records, searching for familiar patterns while remaining alert for new ones. Some observers wonder whether history might be repeating itself, while others argue the recent activity simply reflects normal volcanic behavior. Scientists avoid both assumptions. They know every volcano follows its own timeline, and identical outcomes cannot be expected simply because two mountains belong to the same volcanic chain. That measured perspective explains why history remains such a powerful tool rather than a source of fear. The past does not predict the future with certainty, but it provides the framework for recognizing meaningful change. As Mount Rainier continues revealing subtle signals beneath its frozen slopes, every lesson learned from earlier eruptions becomes another guide for understanding whether today's quiet activity represents routine behavior or the beginning of something far more significant. Scientists know the next signals could change everything. But what will happen when these warnings begin to align? Will the volcano's hidden behavior reveal a new threat scientists fear? And what will they discover in the critical hours ahead as the mountain sends its message? Stay tuned. Warning signs scientists fear most. The recent earthquake clusters beneath Mount Rainier have drawn widespread attention, but scientists are not focused on those tremors alone. Their greatest concern is whether other warning signs begin appearing alongside them. A volcano rarely announces a major change through a single signal. Instead, researchers watch for several different indicators rising together, forming a pattern that points toward increasing unrest. That combination, rather than one isolated event, is what could fundamentally change how experts interpret the mountain's behavior and influence every decision made about public safety. One of the first developments scientists would carefully examine is a noticeable increase in shallow earthquakes. Small earthquakes deep beneath the volcano are not unusual, but activity gradually moving closer to the surface can suggest that underground conditions are changing. The depth, frequency, and location of these events all matter. If they begin clustering in new areas or occurring more rapidly, researchers immediately compare those patterns with observations from previous periods of volcanic unrest across the Cascade Range. Another critical signal involves the shape of the mountain itself. Using GPS stations and satellite radar, scientists constantly measure whether Mount Rainier is expanding or remaining stable. Rapid ground inflation could indicate increasing pressure beneath the surface as magma pushes upward. Even slight changes measured over days or weeks receive close attention because they may reveal processes invisible to everyone standing on the volcano. Ground movement alone proves very little, yet combined with other warning signs, it becomes much more significant. Researchers also monitor volcanic gases escaping through vents and fractures. Rising levels of carbon dioxide or sulfur dioxide may indicate that magma is releasing gases closer to the surface than before. At the same time, instruments track persistent changes in ground temperature around geothermal areas. A temporary fluctuation is rarely enough to cause concern, but lasting increases could suggest that heat is moving differently through the volcano's internal system. Every measurement adds another layer to the overall assessment. Perhaps the most important signal scientists hope not to detect is harmonic tremor. Unlike ordinary earthquakes, harmonic tremor appears as continuous underground vibration, often associated with the movement of magma or volcanic fluids. Its presence would immediately receive intense scrutiny because it represents a different type of activity than scattered earthquake clusters. Even then, researchers would avoid rushing to conclusions until every available source of evidence was carefully examined together. That careful approach explains why today's activity remains under observation rather than emergency response. None of these warning signs is interpreted in isolation, and no single measurement automatically signals an eruption. Scientists are searching for coordinated changes unfolding at the same time, not isolated anomalies. So far, that complete pattern has not emerged. Yet every passing day brings new information, and each fresh observation helps determine whether Mount Rainier is simply following its familiar rhythm or quietly approaching a very different chapter. Scientists may feel confident today, yet Rainier's silent signals demand attention. What hidden clues could emerge next? What secrets might its restless depths reveal? And when the mountain speaks again, will humanity recognize the warning before it's too late? Keep watching. Silence hides unfinished answers. Mount Rainier remains under its current official alert status, and scientists continue to emphasize that nothing in the available evidence points to an imminent eruption. That conclusion is based on careful observation rather than optimism. Although recent earthquake clusters have attracted public attention, the broader collection of monitoring data has not revealed the coordinated changes that would signal a volcano rapidly moving toward a dangerous new phase. For now, experts see an active mountain behaving within the range of expected volcanic activity, but they are far from becoming complacent. The reason for that constant attention lies not only in Rainier's geology, but also in its location. Few volcanoes in the United States stand so close to large populations while carrying such a long history of destructive lahars. Millions of people live, work, and travel throughout valleys that could be affected if conditions changed dramatically. That reality means every new earthquake, every updated measurement, and every scientific report receives extraordinary scrutiny. The mountain's quiet appearance offers reassurance, but it never becomes an excuse to stop watching. Around the clock, monitoring systems continue collecting information from every part of the volcano. Seismic stations record underground shaking. GPS instruments measure tiny ground movements. Satellites scan the surface for subtle deformation, and specialized sensors watch volcanic gases and changing temperatures. Each new observation is compared with decades of previous records, allowing scientists to identify even the smallest departures from normal behavior. This continuous surveillance is not a temporary response to recent activity. It has become a permanent commitment because researchers understand that volcanic systems can evolve gradually over long periods. Even with this remarkable technology, scientists repeatedly caution against confusing speculation with evidence. News headlines and online discussions often focus on dramatic possibilities, encouraging people to interpret every earthquake as the beginning of an eruption. Others assume the absence of alarming announcements means nothing important is happening. Neither conclusion reflects how volcanoes are actually studied. Scientific confidence comes from multiple independent observations supporting the same explanation, not from isolated events or public opinion. Careful analysis remains the strongest defense against both unnecessary panic and dangerous complacency. That balanced approach has become one of the most valuable lessons learned from decades of volcano research. Scientists are not waiting for disaster before paying attention, nor are they treating ordinary volcanic activity as an emergency. Instead, they remain prepared for either possibility by allowing evidence to guide every decision. Their constant vigilance protects surrounding communities not by predicting the future with certainty, but by recognizing meaningful change as early as possible. For now, Mount Rainier remains a restless but carefully watched giant. Its recent activity has raised important questions without providing alarming answers. The mountain has not revealed what comes next, ensuring that every quiet signal detected beneath its frozen slopes will continue drawing the full attention of the people whose job is to understand it before anyone else can. So, what do you think? Could Washington's most dangerous volcano's recent activity be nothing more than routine volcanic behavior? Or are scientists witnessing the earliest signs of a much bigger story? We'd love to hear your thoughts in the comments below. Don't forget to like, share, and subscribe.